All right, let's take a look at example 5 here. In this case, because we do have a square root, and there's, well, in the top, we just have a constant of 1. Sometimes when you've got a square root in the bottom or elsewhere in the problem, if you have something else to work with, you can sometimes get away with doing a u substitution. So for instance, if we had 2t minus 6 in the top, or any scalar multiple of 2t minus 6 in the numerator, then we could do a u substitution on the inside, let u equal t squared minus 6t plus 5. But because there is no scalar multiple of that t expression in the numerator, u sub's not going to work as is. So we're going to try and do a trigonometric substitution. But a trigonometric substitution, we always use it when it's of the form, something squared minus something squared. Whether it's x squared minus a squared, x squared plus a squared, or a squared minus x squared, we always have just two things being squared and then either added or subtracted from one another in some order. So we can't use a trig sub as is. We're going to have to do something first to get it into one of these formats. And this is where completing the square comes into play. So what we'll do is we'll take a look at t squared minus 6t plus 5, and we'll do the usual completing the square routine where we take this constant, move it over to the side, and then we want to add something here and subtract something. It's the same thing, we're just adding it in one area of the equation and subtracting it in the other. So what we need to add here for completing the square purposes, it's going to be half of this number squared. So this would be negative 3 squared, so 9. So we add 9, we subtract 9. Now these first two terms here, these first three terms, I should say, if we associate that, that's a perfect square trinomial, and that collapses down into t minus 3 quantity squared. And then these last two terms here, we can group them together to give us negative 9 plus 5, so what's that going to be? Negative 4? Negative 4. So through completing the square, we've changed this integral slightly. We have it written in the format t minus 3 quantity squared minus 4 dt. So now what we can do is actually a u substitution before we do the trig substitution. We'll let u equal t minus 3, so then du is dt, and that this integral turns into the format desired, which is u squared minus 4 du. Something squared minus something else, or plus. Okay. Now that we have that taken care of, we can do the trig sub. So for the trig sub, we'll let u equal 2 secant theta. Du is 2 secant theta tangent theta, d theta. And we can go ahead and plug that in. So let's erase that. This would be equal to the integral of, in the denominator, we're going to have a 4 secant squared theta minus 4. And then in the top, our dt, our du becomes a 2 secant theta tangent theta d theta. All right. So the square root, the denominator becomes the square root of 4 tan squared theta. Of course, it's a perfect square, so that turns into 2 tan theta. And then we can cancel the tan theta with a term in the top. So that looks like, we can also cancel the 2's. So the 2's cancel. And then this whole integral just collapses down into the integral of secant of theta d theta. So that's nice. And this is also a 7.2 integral. We talked about secant cubed in the previous video when we did example 1. So I'm just going to write a 7.2 in a circle here. This is going to be the natural log absolute value of secant theta plus tangent theta, I believe. Yep. So then, like before, we need to use a right triangle to go back and figure out what secant and tangent are. Well, thankfully, from our substitution, we know that secant of theta is u over 2. So this becomes the natural log absolute value of u over 2, plus we need to know what tangent is. So if secant is u over 2, that means cosine of theta is 2 over u. So then our right triangle that we can just build, place theta at one of the two non-right angles, and then relative to this theta, cosine is adjacent over hypotenuse. So the adjacent side gets a 2, and the hypotenuse is a u. So then this side length here, the opposite side length, is found by Pythagorean theorem. So this is u squared minus 4, and that matches our integrand, so that's good. So now this tells us that tangent of theta is opposite over adjacent relative to the placement of this angle theta. So opposite is the square root term over adjacent, so 2. So that goes in for tangent of theta. All right. We can continue. I'll just simplify this into u plus the square root of u squared minus 4 all over 2 plus c. And then we've got u. U is t minus 3, all the way back to our original variable. So t minus 3. So natural log, absolute value, t minus 3 plus the square root of t minus 3 quantity squared minus 4 all over 2 plus c. All right.